This is SpaceTime, Series 28, Episode 103, for broadcast on the 27th of August 2025. Coming up on SpaceTime, an invisible monster hiding in the darkness of space. A meteor slams into a house in Georgia. And the likely origins of the asteroids Bennu and Ryugu. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have uncovered an invisible monster hiding in the darkness of space. Like a scene out of a sci-fi horror movie, the behemoth was discovered lurking 600 million light-years away in the inky black depths between stars. There, it was consuming entire stars and planets that ventured too close. In fact, that's how the monster was uncovered. Astronomers spotted it using NASA's Hubble and Chandra space telescopes, together with a Very Large Array radio telescope in New Mexico, and determined that it was a rogue supermassive black hole. They're called black holes because nothing, not even light, can escape them. So this monster lies in wait, completely invisible, until its next victim comes within reach. Now, the thing is, these demons are supposed to reside in the heart of galaxies, not in the black emptiness of deep space. The sneaky black hole betrayed its presence in a newly identified tidal disruption event where a hapless star was ripped to shreds and swallowed in a spectacular burst of radiation. A tidal disruption event occurs when an infalling star is stretched or spaghettified by the enormous gravitational tidal forces of a black hole. The shredded star's remnants are pulled into a circular orbit around the black hole called an accretion disk. There, the star's material is crushed and torn apart at the subatomic level. This releases vast amounts of energy. Most of the star's material and energy will fall beyond a point of no return called an event horizon, where it will plummet forever into the black hole singularity. These disruption events are powerful probes of black hole physics, revealing conditions necessary for launching jets and winds when black holes are in the midst of consuming a star. The new tidal disruption event, catalogued as AT-2024-TVD, allowed astronomers to pinpoint the wandering supermassive black hole, showing it to be well offset from the centre of its host galaxy. The findings, reported in the Astrophysical Journal Letters and on the pre-press physics website archive.org, describe a million solar mass black hole not residing where it should. Out of approximately 100 tidal disruption events recorded by optical sky telescopes so far, this is the first time an offset tidal disruption event has been identified. The study's lead author, Yuan Yao from the University of California, Berkeley, says AT-2024-TVD is the first offset tidal disruption event captured by optical sky surveys. And it opens up the possibility of uncovering this elusive population of wandering supermassive black holes with future sky surveys. Now, this supermassive black hole wasn't alone in its host galaxy. The centre of the galaxy already hosted a supermassive black hole weighing over 100 million times the mass of our Sun. Now, by comparison, the supermassive black hole at the centre of our own Milky Way galaxy, Sagittarius A star, has about 4.3 million solar masses. Hubble's observations show that AT-2024-TVD is some 2,600 light-years from the more massive black hole at the galaxy's centre. Now, that's about a tenth of the distance between our Sun and Sagittarius A star. Now, the bigger black hole at the centre of this distant galaxy spews out energy as it accretes infalling gas, and so it's categorised as an active galactic nucleus, or AGN. Strangely, the two supermassive black holes in this distant galaxy are not gravitationally bound to each other as a binary pair. They simply coexist in the same galaxy. Astronomers think the smaller black hole may eventually spiral into the galaxy's centre in order to merge with its bigger companion. But for now, they're too far separated for there to be any gravitational interaction. Until now, theorists haven't given much attention to offset tidal disruption events. But Yao thinks that this discovery will motivate more and more astronomers to start looking for more examples. Needless to say, we'll keep you informed. This is SpaceTime. Still to come, a meteor slams into a house in Georgia, and the likely origins of the asteroids Bennu and Ryugu. All that and more still to come on SpaceTime. scientists have had an amazing opportunity to examine a pristine meteorite fragment that crashed into a house in Atlanta, Georgia earlier this year. The extraterrestrial visitor slammed through the roof and ceiling and into the living room of the house in Henry County on June the 26th, missing the owner by just meters. Earlier, hundreds of eyewitnesses saw the fireball as it streaked across the daytime sky over the southeastern United States. Planetary geologist Scott Harris from the University of Georgia was able to retrieve several fragments from the house for detailed examination in order to determine the meteor's origins and classification. Harris eventually gathered 23 of the 50 grams of meteorite recovered from the house. Using optical and electron microscopy, Harris and colleagues analysed the fragments, determining their low-metal L-type chondrites. Now, that suggests this meteor formed around 4.56 billion years ago, and it formed in the presence of oxygen. Harris says it belongs to a group of asteroids from the main asteroid belt between Mars and Jupiter that astronomers now think can be tied to the breakup of a much larger asteroid about 470 million years ago. But in that breakup, some pieces got flung into Earth-crossing orbits, and given enough time, their orbits around the Sun and Earth's orbit around the Sun ended up being at the same place at the same time. Meteorites are named after the locations they land in, so these fragments will eventually be named the McDonough meteorite when the study is officially published in the Meteoritical Bulletin. Harris says a fireball entered the Earth's atmosphere faster than the speed of sound, but the atmosphere is very good at slowing things down. Still, Harris says you're talking about something twice the size of a .50 caliber bullet travelling at around 1 kilometre per second, so it still has enough momentum to not just go through the roof of the man's house, but also his HVAC duct and the ceiling and leave a solid dent in his floor. Harris says it was the 27th meteorite recovered in Georgia and the 6th witnessed fall.
What was witnessed by many people across North Georgia and certainly the metro Atlanta area of a fireball, sometimes called a bolide, coming in through the atmosphere. It just broke apart in its flight, probably a couple of miles still up in the atmosphere, and then those pieces made it to the ground as individual meteorites. But one of them actually penetrated a house, went right through the roof, through the ceiling, and into the floor. And we've had the pleasure and the opportunity to examine that, both the rock as well as the dynamics of entry through the house. Understanding what caused that. Was this the velocity that it maintained simply flying through the air? Was it an extra kick from that disruption in the air? Where in that process did it get the momentum that we see evidence for in the collision? There's a link between the physics of going through something and the materials, though, in terms of their strength. A lot of these asteroids have undergone a lot of collisions, a lot of internal damage, billions of years before they encounter Earth. So we think it may have still been traveling at least many, many hundreds of meters per second, even up to as much as 1 kilometer per second as it went through the house. The homeowner was about we measured it exactly, it was 14 feet away. So still to this day, we have only one absolute clear record of a person being hit back in the mid-1900s in Sylacauga, Alabama. Impacts, whether they be large or small, are the only thing that we have a potential of actually stopping if we have enough information in advance about them.
That's Dr. Scott Harris from the University of Georgia. And this is SpaceTime. Still to come, the likely origins of the asteroids Bennu and Ryugu, and later in the science report, new research shows that scientists can now tell what you're going to buy simply by scanning your friend's brain. All that and more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, Insta360, the trailblazers in 360 and action cameras, pushing the boundaries of what's possible for creators everywhere. Last week, Insta360 dropped their latest game changer, the Go Ultra, a pocket-sized camera that's redefining how you capture life's adventures. Imagine it, a camera no bigger than an Oreo, weighing just 53 grams, yet packed with the power to shoot buttery-smooth 4K video at 60 frames per second. It's small enough to slip into your pocket, but delivers professional-grade footage that'll make your vlogs, travel diaries or family moments look absolutely stunning. What makes the Go Ultra stand out? The standalone camera is the IPX8, waterproof up to 33 feet. So it's ready to roll whether you're surfing, swimming or caught in the rain. And the Go Ultra's upgraded sensor and AI chip ensures your shots are always crisp and vibrant day or night. Low light scenes, no problem. The pure video mode uses AI to reduce noise and boost dynamic range, so your nighttime adventures also shine. The Action Pod's 2.5-inch flip touchscreen lets you frame shots, tweak settings, or even control the camera remotely for all those hard-to-reach angles. And here's the best part. For the first 30 SpaceTime listeners who purchase the Insta360 Go Ultra at store.insta360.com, you'll score a free Sticky Tabs accessory to mount your camera on anything from backpacks to winter jackets. Just use the promo code SpaceTime at the checkout. That's store.insta360.com, promo code SpaceTime. Just go to our links page for full details and descriptions. So don't miss out on this titan of a camera that's ready to capture your world like never before. That's the Insta360 Go Ultra. And now it's back to our show. Astronomers have identified that the near-Earth asteroids Bennu and Ryugu may both be part of the same Polarna family group of asteroids. A report in the Planetary Science journal claims spectral data of the main belt asteroid Polarna matches the samples of Bennu and Ryugu, which will return to Earth in separate sample return missions. Polarna is a collisional family of space rocks which orbit the Sun in the main asteroid belt between Mars and Jupiter. The study compared spectroscopy data from Polarna with spacecraft and laboratory data from both Bennu and Ryugu samples, discovering similarities in their near-infrared signatures, supporting the idea that they've originated from the same parent body. The study's lead author, Annika Arredondo from the Southwest Research Institute in San Antonio, Texas, says it seems that early on in the formation of our solar system, large asteroids collided and broke into pieces, forming asteroid families, with Polarna the largest remaining body in one of these families. The hypothesis suggests that the collision not only created Polarna, but also Bennu and Ryugu. Now, to test this idea, Arredondo and colleagues started looking at spectra from all three bodies and then comparing them to one another. They used the Webb Space Telescope to observe Polarna using two different spectral instruments, focusing on both the near-infrared and mid-infrared wavelengths. They then compared that data with spectral signatures from physical samples of Ryugu and Bennu collected during two different space missions. JAXA, the Japan Aerospace Exploration Agency's Hayabusa 2 spacecraft, rendezvoused with the asteroid Ryugu in 2018, bringing back samples in late 2020. And NASA's OSIRIS-REx mission visited the asteroid Bennu in 2020, returning samples back to Earth in late 2023. Both Bennu and Ryugu are relatively small compared to Polarna. Bennu is around half a kilometre wide, about half the size of Ryugu. Now, by comparison, Polarna dwarfs both, measuring roughly 60 kilometres across. The authors believe that Jupiter's immense gravitational forces ended up pushing both Bennu and Ryugu out of their orbits close to Polarna. Now, the authors admit that the spectral data from all three asteroids has variations and differences, but not enough to disprove the hypothesis that they all share a common origin. After all, Polarna, Bennu and Ryugu have each undertaken their own individual journeys through the solar system since the impact that formed them. Bennu and Ryugu are now much closer to the Sun than Polarna, so their surfaces are likely to be more affected by solar radiation and particles from the Sun. Likewise, Polarna is possibly older than Bennu and Ryugu, and thus would have been exposed to micrometeorite impacts for a longer period of time. And that would have changed aspects of its surface, including its surface composition. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that using a fan in very hot temperatures won't actually keep you cool, and in fact may put extra strain on your heart if you're not staying hydrated. A report in the Journal of the American Medical Association shows that fans generally become detrimental to your health once the ambient temperature hits around 39 to 40 degrees Celsius. The authors tested how hydration impacts this by exposing 20 people, either well hydrated or dehydrated, to 3 hours of heat at the threshold at which fans stop helping. They say only those who were well hydrated felt any relief from the fan, while dehydrated participants actually saw worsened heart strain when the fan was on. Overall, the researchers found heart rate and core temperatures were much higher in dehydrated participants, underscoring the importance of good hydration during heat waves. Well, here's something to creep you out. Scientists have discovered that they can tell what you're likely to buy simply by scanning your friend's brain. A report in the journal Neurosci shows that close friendships can lead to friends' brain activity and even their shopping habits becoming similar. The authors ran a series of experiments in which 175 participants of varying degrees of friendship were asked to evaluate various products and determine whether they'd buy them or not. They found friends were more likely to purchase the same products compared to strangers. Now, in tandem, they scanned the brains of 37 people, also of varying degrees of friendship, as they watched TV ads for various products. Here, they found that as friends viewed ads together, their brain activity synchronized with increased activity seen in brain regions linked to object perception, attention, memory, social judgment, and reward processing. The authors say they were then able to predict which good a person would likely buy based on their brain activity alone, and the goods their friends were likely to purchase as well. A new study has shown that while artificial intelligence chatbots are great at answering medical questions when the answer's easy to find online, their accuracy drops dramatically when they're asked to use reasoning alone to determine an answer. A report in the Journal of the American Medical Association tested 6 AI chatbots to see if the chatbots could use reasoning to come up with an answer rather than simply parroting one they found online. The authors asked the chatbot 68 questions. But in data being searched by the chatbots, they replaced easily findable answers with the phrase "none of the other answers," so the AIs would have to reason their way to a solution. And this made the chatbots a lot less accurate, with DeepSeek getting 6 of 48 questions wrong and ChatGPT stuffing up 18 of the answers. The worst performer was Facebook's Meta, which got 26 questions wrong. You wouldn't want to go to that doctor. The findings show that you really can't rely on AIs to provide accurate medical answers using reasoning. The authors say their clinical applications, therefore, should be limited to support roles only and should always be checked over by a healthcare professional. Australian Telstra Big Pond internet users are suffering more failures through their NBN broadband connections. The problems are now so bad that many customers are looking at switching to rival options like Starlink. So, has the NBN been a failure? And if so, what are the alternative options? To find out, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
We live so much of our lives online in some capacity. And when one major network goes out, or when the NBN goes out just in your street, it's just you, for example, I mean, it's a huge disruption.
The NBN is causing problems. It's not as reliable as it should be. It was supposed to be the information superhighway. It's more like a GO track, really.
Best alternatives to the NBN are the 5G networks, a competing broadband network like the Vision network in Canberra and in some other places, and also Elon Musk's satellite. Now, there will be more satellite providers, but Elon Musk's satellite system is available anywhere around the world just about, and at very high speed. This is Starlink, Elon Musk Starlink. For many people, it's the alternative, but you also do have 5G modems from Vodafone, Telstra, and Optus, and for people listening around the world, your phone companies will offer this 5G modem to you. And also, Amazon's got this Project Kuiper, which is their own version of satellites delivering broadband from the sky. So we've got more connectivity options than ever before. And of course, a lot of people use their 5G and 4G phones as hotspots, which you can use anywhere, as opposed to the Wi-Fi that people use in cafes or airports, because they want a private connection. They don't have to have a VPN, and people aren't trying to hack into it. So we do have a wonderful range of connectivity, and you do not have to use the NBN if you don't want to. And people who really are concerned and have the capacity to pay for it will have like a 5G modem and or a Starlink and or an NBN fixed connection. So they've got redundancy and backup. But outages happen, and unfortunately sometimes it can take several days to fix. So if you don't want to be on the NBN, you definitely have several choices.
That's Alex Zaharov-Reutt from TechAdvice.life. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.